5. Newton's Laws of Motion. In January 1993, the 53rd Space Shuttle mission crew brought some toys on board. During the flight, crew members took the toys out and played with them to see how they would work in microgravity. Can you imagine trying to shoot a foam ball through a hoop while floating around in the space shuttle? How about running a toy car around a loop track? Would that work? Do an internet search on toys in space to learn more about these interesting space shuttle experiments. This chapter will help you use the laws of motion to explain the motion of objects on Earth and help you predict how toys will work in space. Sir Isaac Newton, 1642 to 1727, discovered answers to many questions about motion. Many historians believe Newton's ideas about motion were the beginning of modern science. Read this chapter and you will know all about motion too. First law. Sir Isaac Newton, an English physicist and mathematician, was one of the most brilliant scientists in history. Before the age of 30, he had made many important discoveries in physics and had even invented a new kind of mathematics called calculus. Newton's three laws of motion are probably the most widely used natural laws in all science. The laws explain the relationship between the forces acting on an object, the object's mass, and its motion. This section discusses Newton's first law. Imagine you are playing miniature golf. It is your turn. What do you do to move the golf ball toward the hole? Do you yell at the ball? Of course not. You hit the ball with the golf club to get it rolling. In physics, hit the ball means the golf club applies a force to the ball. This force is what changes the ball from being at rest to being in motion, figure 5.1. Motion can change only through the action of a force. This statement is the beginning of Newton's first law. What happens next? The ball rolls some distance, slows down, and eventually stops. For a long time, scientists thought that the natural state of all things was to be at rest or stopped. They believed that force had to keep being applied to keep an object moving, even if it was moving at a constant speed. Things stopped moving because being stopped was the natural state of being. Scientists thought that constant motion required a constant supply of force. They were wrong. The golf ball stops because the force of friction keeps acting on it until there is no longer any motion. Suppose the golf course were perfectly level and had no friction. After being hit with the golf club, the ball would keep moving in a straight line at a constant speed forever. The ball would neither slow down nor change direction unless another force acted on it. In a world without friction, the golf ball would just keep going forever once the force from the club acted on it. Being stopped or moving with constant speed and direction are both natural states of motion, and neither one requires any force to sustain it. The law of inertia. Newton's first law says that objects continue the motion they already have unless they are acted on by a net force, the sum of all the forces acting on an object at any given time. When the net force is zero, objects at rest stay at rest, and objects that are moving keep moving in the same direction with the same speed. The first law says there can be no change in motion without a net force. That includes slowing down. It takes a net force, often friction, to make the thing slow down. If forces are truly balanced, a moving object will keep moving forever with the same speed in the same direction. Changes in motion come from unbalanced forces. Forces are unbalanced when the net force is not exactly zero. Forces are balanced when they add up to a zero net force. Forces are always balanced in equilibrium. A rolling golf ball is not in equilibrium because friction is an unbalanced force. The first law is often called the law of inertia because inertia is the property of an object that resists changes in motion. Inertia comes from mass. Objects with more mass have more inertia. To understand inertia, imagine moving a bowling ball and a golf ball which are at rest. A golf ball has a mass of 0.05 kilograms, and the average bowling ball has a mass of 5 kilograms. A bowling ball is 100 times the mass of a golf ball, so it has 100 times more inertia, which needs more force to start moving. Of course, the bowling ball needs more force to move at the same speed as the golf ball, assuming the forces act for the same length of time. The bowling ball needs more force because a bowling ball has more inertia than a golf ball. The greater an object's inertia, the greater the force needed to change its motion. To hit a golf ball, the force from the club is not the only force that acts on the ball, figure 5.3. The ball's weight, the normal force from the ground, and friction are also acting, which force demonstrates how the ball will move. You are right if you answered all forces together. There is almost always more than one force present because gravity acts on all the objects. The first law is written in terms of the net force because that is what affects motion. Individual forces only matter in that they contribute to the net force. Recall that force is a vector. When adding up forces, the direction of the forces matter. To find the net force, you must include positive and negative signs to account for the direction of the forces. Here and answer these questions.